Okay guys, precipitation reactions. This is sort of our last big doozy when it comes to reactions. So I'm going to recommend that you make sure you concentrate fully on this lesson, and not only concentrate fully, take these notes and then watch this again. Okay, this is going to be one that you'll really benefit from absorbing the information multiple times, because it is a little bit different. We are going to practice this concept in class and make sure that we have it. You need to practice this as a group, and you need to work with your lab group and partners to make sure that you understand what you're doing. So a precipitate, solid, or insoluble are all terms used to describe when a solid forms in a double displacement reaction. So this is a specific part of a double displacement reaction. So we have our synthesis reactions, we have our decomposition reactions, we have our single replacement, and we have our combustion reactions, and none of those are impacted by this precipitating. So this precipitate idea, when we mix chemicals together, a lot of times we form a solid, and we could say it's a precipitate, we could say it's a solid, we could say it's insoluble. An example of this is when you did the lab with the lead and the iodide, and you formed that yellow compound on the watch glass. You just did that in the reactions types lab. You look at that yellow compound. That yellow compound, although it's looks aqueous, it is a solid, and if we let that settle out, we could filter off the liquid and we would have that solid yellow. So that's just one example of a precipitate, and you'll see lots of other ones as we go through the lab on this. Aqueous or soluble is the terms that are used to describe things that do not form a solid in solution. So aqueous, that AQ, we've started to introduce this idea, AQ, means it does not form a solid. It stays dissolved in solution. So solubility rules. We have 5 rules that we need to learn in order to be able to understand this material. And I said they're really great. If you look on our website, I've linked a couple of songs. Sometimes songs help people learn the material and memorize it. So there's a couple songs to play through to help you learn these rules. But here they are. Make sure you get them all listed. All compounds of group 1, which are alkali metals, and ammonium, are soluble. So if you have anything with an alkali metal, anything with lithium or sodium or potassium or rubidium or cesium, it's going to dissolve. Okay, it means it's not going to make a solid. Ammonium is always going to be aqueous. Acetates, my favorite, C2H3O2 -1, and nitrates, NO3 -1, are soluble. Okay, those ones all dissolve. Group 7, fluorine, chlorine, bromine, and iodine, they all dissolve as well, except when they are with silver, mercury 1, and lead. And remember, our mercury 1 is Hg2 + 2. All sulfates are soluble, so SO4 -2 is soluble, except with barium, strontium, calcium, silver, mercury 1, and lead. So the silver, mercury 1, and lead is repeated, and barium, strontium, and calcium are the new ones added on for sulfates. And then except for ones that are in Rule 1, with the alkali metals, carbonates, hydroxides, oxides, sulfides, and phosphates are insoluble, meaning they precipitate. Okay, so we're going to be, the only way to really get these rules is A, we sort of have to memorize them, and B, we have to practice them. So the sooner you start to learn them, whether you make flashcards or whatever, and then can practice them in class, the better off you'll be. Molecular equations. So we can do this. Potassium chromate plus barium nitrate. This is what we've been working on with predicting products. So K plus CrO4 -2, Ba plus 2, NO3 -1. So I'm going to go ahead and put this together. I have K2CrO4 plus BaNO3, 2. And I'm going to put my opposite partners together. So these guys will go together. So then I have KNO3. And then these guys go together. Plus BA. I'll keep my parentheses around those just to make it easier to see. CrO4. Oh gosh. CrO4. Done. Okay. So before we start including solid, liquid, gas, and aqueous, we need to balance. I have 2 nitrates, I have 2 potassium, so this one's pretty easy. I can put a 2 here. So now we need to start including solid, liquid, gas, and aqueous. So here I have potassium chromate. If I flip back to my rules, all compounds of group 1 with alkali metals are soluble, which means they are aqueous. So anything with group 1, so this potassium here, this is aqueous. And the potassium is here, this is aqueous. Here I have barium and nitrate, and I know I had some sort of rules about barium. Well, barium precipitates, but only with sulfate. But nitrates are all soluble. So this one is going to be aqueous. So we have aqueous, 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 which means that barium chromate must be our solid. Okay, so looking at this, I'm generally looking to see if everything is aqueous, which sometimes happens, or if I'm going to make a solid, there's only ever going to be one solid, and that solid is going to be in the products. That solid is never going to be in my reactants. So these two will always be aqueous. They have to be. And these two will either both be aqueous or one aqueous and one solid. And that's going to be real important, because here's what's going on. If we want to get a better picture of what's occurring in the reaction, we need to split apart all the things that are aqueous. So we call this, the last one was a molecular equation, and everything we've done is a molecular equation because there are molecules. Now we are doing what's called the complete ionic equation. So here's what we started with, and here was our answer from the last page. I just retyped it so that we could have it here. So now, to do a complete ionic equation, I need to split apart anything that is aqueous, not solids. I'm not splitting solids apart. So this is aqueous. I need to split it apart. But I don't write it as K2. I'm writing it as ions. And so what this is telling me is that there are 2 potassiums. So I'm going to take this 2 because I can't write it like that. That's just not what we do. So I need to take this 2. Doesn't want to erase there. Here we go. I need to take this 2 and move it in front. So I have 2K plus 1. And then this is aqueous. There's so much little symbols with this. I have 1 CrO4. So plus CrO4 negative 2 aqueous. Plus, now I need to split this apart. I have 1 barium, Ba plus 2 Aq, and I have 2 NO3s, but I'm not going to put this on the outside of the parentheses. I'm going to bump it from here. Anything that's out here gets bumped to the front, so it becomes 2 NO3. And actually, I don't need the parentheses, but since I have them, I can leave it there. Minus 1. Minus 1. I like it better without the parentheses, but if you do, parentheses can go there. And then this is also aqueous. It's going to yield, I'm going to split this apart, so I have 2KNO3. So I have 2K plus aqueous plus 2 NO3 minus 1 aqueous. Okay. And then my solid I keep together, so plus BaCrO4 solid. Okay. So Couple things that are important is that when I look at this here, okay, if I have something on this side here, it better match what's on this side. So these individual ones that I split apart better look exactly the same. So let's take a picture and see what's going on here. Okay, so here's my 4 ions. This is what I started with. They're all aqueous, okay? All of these are aqueous. They're all floating around in solution. We know that the chromate and the barium precipitate, so they mix together, and then these guys form this nice crystal down here and sink to the bottom. That's our precipitate. While the K and the NO3 stay in solution. And so then we get to what's called the net ionic equation. Remove anything from the equation that is not a part of the precipitate. They are spectator ions. So remove anything from the equation that is not a part of the precipitate. They are spectator ions. Okay, so if we look back at our picture, here, these guys that are blue, they're just hanging out here and they haven't changed. They're just watching this reaction. So nothing, they are not a part of this reaction. The same is true for these red guys. Potassium's just hanging out here, spectating what is known as our actual reaction. So if I go back to my reaction, here we go. So if I go back to my complete ionic reaction here, I can cross out anything that I see that's the same on both sides. So here, K plus is exactly the same. NO3 minus is exactly the same. Then what I have left, everything that I have left, and left, is what is called my net ionic equation. QN means equation. So essentially I just recopy what I have there. CrO4 minus 2 AQ plus Ba plus 2 yields BaCrO4 solid. So there is what's left. That is my net ionic equation, because that is really what's happening right here. That's really my equation. And that's the notes we took on net ionic. So, very quickly, before our time runs out, let's do potassium chloride and silver nitrate. So I'll put my ions up here. K plus 1 and Cl minus 1, Ag plus 1, and O3 minus 1. So I have my molecular equation, my complete ionic, and my net ionic. So for my molecular equation, I have K and Cl, and then I have Ag and NO3. And then I'm going to go ahead and pair up my opposites, so these two. So I have KNO3 plus, and then Ag and Cl. I need to put in now my solids and aqueuses and stuff. Everything group 1 is aqueous, so potassium is aqueous. Everything with nitrate is aqueous, so aqueous. Group 1 and nitrate, aqueous. And this is one of those exceptions to group 7, so that's my solid. It is already balanced, 1, 1, 1, 1. Complete ionic. Split apart the aqueous things. So K plus 1, aqueous, plus Cl minus, aqueous, plus Ag plus 1, aqueous, plus NO3 minus 1, aqueous, yields K plus 1, aqueous, plus NO3 minus 1, aqueous, plus AgCl solid. Always leave my solids together. Net ionic, very quickly here, I'm going to cross out anything that's the same. K plus 1 and K plus 1, nitrate and nitrate, so those are my ones. I don't want you to actually cross these out, because if I have to grade that, that's going to be a real bear for me. So underline them, or underline what you want to recopy or something like that. But I'm doing it for illustration purposes here. I have that, plus that,